Okay. Nope. Wait. All right. Hey, everyone. Welcome to part number 3 of Nerd Nite Stream You in September, our 4-part series happening obviously every Sunday night here in September, as we are now 2 days away from fall. We are kissing summer goodbye, but that's probably good because that means that 2020 will be over sooner than later as well. So yeah, good times. Everyone, as always, do note a couple of things. First, obviously, you've got the chat area there in Facebook. We have 4 delightful and intelligent and wise and witty presenters, as always. So feel free to ask them questions and make comments to them. And as always at Nerd Nite, since we do encourage at the live shows face-to-face, we do encourage positive heckling. You can also positively heckle them in the chat area as well. And we will relay all questions and comments and positive heckles to them throughout the evening. And I do want to mention that this is being recorded, as have all of our other virtual Nerd Nights. And Facebook generally is very good about posting the recordings. In fact, it usually happens within 30 to 60 seconds after an event ends. So you can view this at 10:01 Eastern tonight or 9:01 Mountain Standard Time. And, tell all your friends because it's going to be swell. So the reason we're all here, you're not really here to see me today. You're here to see our 4 delightful presenters. Kicking off in just a couple of seconds is going to be Chequita talking about are Martians real? Maybe, maybe not. She's coming to us from Greenville, North Carolina. Then we're going to turn it over to Nerd Nite Miami with Morgan talking about, it's called Did You Try Turning On and Off and On Again? We'll let you figure out what that is, or maybe you already read the description online and I won't ruin it for you. Then at 9 o'clock at the top of the hour, we're going to have Derek Beck. He's an astronomer from Nerd Nite Orlando. He's spoken at many a virtual and face-to-face Nerd Night, so he's going to be back talking about cruising the solar system. And then Kasha is bringing us home tonight. She's going to be the grand finale, talking about the science of science comedy. And we'll mention this again earlier. She's putting us all to shame. She's, as a stand-up comic, she is actually standing up from her home, which I think is both cool and slightly crazy. So, which sounds like Nerd Night. So I think she's doing it the right way. Okay, so Morgan, Kasha, you can go ahead and just disable your webcam and mics for now. And I'm going to turn it over to Chequita, coming to us from Greenville, North Carolina. She has been a co-boss there for a couple of years, and the secret that some of you may or may not know is that she also is there with Chris Balakrishnan, who is, of course, the godfather of Nerd Night. But luckily, because he is generally shy and lazy, he don't want any of the business of really doing the day-to-day Nerd Night stuff in Greenville. So he lets her do all the heavy lifting because he's lazy and slackerly that way. So with that, I have nothing much to say. I think if you ask me if Martians are real, I would say obviously yes, because everyone knows that they are green and small. So, I mean, if they aren't real, how could everybody agree on that? So that's my very scientific conclusion. I'm going to go ahead and disable my stuff. Chequita, go ahead, take it away.
Thank you very much for that wonderful introduction, Matt. So I'm going to go ahead and start sharing my screen. Hopefully. Maybe not.
We have faith. It's going to be great.
Let's see here. Hopefully this is working. Can you guys see the PowerPoint? Man,
yeah, you're all good.
Can you see the actual PowerPoint, or are we in presenter view?
We are in presenter view, but it's great. We get to preview what's coming up too. It's like we're in on the joke.
I have no idea how to work Zoom. That's fine.
No worries. It's totally fine.
Okay, well, we'll just move forward with it.
Everyone, pay attention to what's on the left of your screen. Ignore the stuff on the right.
So like Matt said, I'm from Nerd Nite Greenville, North Carolina, not South Carolina or any of the other Greenvilles in America. And at Nerd Nite Greenville, we really embrace the heckling. So I'm very sad that I will have no idea what you guys are saying because I'm staring at my PowerPoint. But I very much encourage you to, if you have a funny joke that's better than any of the funny things that I'm trying to say, please include those in the chat box. I will enjoy them later. I'm very much looking forward to your questions. And with that, I will kind of introduce myself a little. So my name is Chequita Brooks. I'm a PhD student at East Carolina University, which is where the godfather of Nerd Nite works in the biology department. He's on my committee. And so I am a nerd, I guess. I have been a Nerd Nite boss for quite some time, like Matt said. And tonight I want to talk to you guys about whether or not Martians are real. So Martians were first spotted in 1955 in Kentucky. There were 11 eyewitnesses in a cabin in the woods, and they described them as little gray men. So these were called the Hopkinsville Goblins at the time. The family actually went to the cops to ask for help, but bum, 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 no one ever found anything. And that's probably because what the family actually saw was a bunch of great horned owls. So what I have in the top right corner here is a great horned owl on night view. And so what you can see is they have really glowy eyes, and obviously in the dark you're not going to see a lot of their color. And also great horned owls are really scary, and if that thing was running towards me in the middle of the night, I would probably think I was being attacked by aliens too. So with that being said, if I've already kind of told you that the folklore about the little green men, right, which got kind of messed up in translation from gray, if I'm not going to talk about them really, then what am I going to talk about? Well, first I'm going to talk about why they probably wouldn't come to Earth anyway. If I was an intelligent life form from space, then I would also be concerned that they were going to try and naturalize me in the United States, which is what happened to the aliens from Mac and Me and the Cat from Outer Space. And if you've never watched either of those movies, congratulations. You've probably saved yourself a few hours. So we are going to talk tonight about astrobiology. So astrobiology is the branch of biology concerned with life on Earth and in space. So specifically, whenever we're talking about astrobiology, most astrobiologists would also consider themselves microbiologists. So really what we're talking about is not multicellular advanced life forms in space. We're talking about unicellular organisms in space. So a lot of you guys are probably familiar with the word bacteria. So bacteria are single-celled microorganisms, which means they're very, very small, and they cannot be seen with the naked eye. Many of you guys probably think of bacteria as something that infects your wounds or makes you sneeze, but that's not all the bacteria do. So I actually study bacteria that eat rocks, or in my case, geologically important elements. So I study a bacteria that eats iron, and actually whenever it eats the reduced form of iron, which is aqueous in solution, which means that it's dissolved so you can't see it, then it oxidizes it and makes rust. So then we're actually able to observe basically bacteria poop. But similarly, we're interested in what kind of microbes may live on other planets. And to kind of talk a little bit more about that, we're going to go over some introductory microbiology. So there are two big categories of bacteria. There are aerobic bacteria and there are anaerobic bacteria. Aerobic bacteria use oxygen just like we do. So they need to take in oxygen in order to carry out a process called cellular respiration, which is how we make energy. Anaerobic bacteria cannot use oxygen. Oxygen is actually really toxic to them. And the reason oxygen is really toxic to anaerobic bacteria is because whenever we breathe and we use that oxygen, it's creating byproducts. So earlier I was talking about bacteria that form rust as a byproduct of their energy. So they have to develop some kind of way to deal with going from something that was dissolved in solution to something that's a solid. It's kind of the same thing with using oxygen. So when you use oxygen and breathe, then you create byproducts like hydrogen peroxide. So our cells and the cells of bacteria that are aerobic are able to deal with that hydrogen peroxide, which dissolves proteins. So if you've ever put a hydrogen peroxide on a cut, you'll notice it's bubbling. That's actually where it's reacting with some of your enzymes, and it denatures them. And it can also turn into hydroxyl radicals. And hydroxyl radicals can actually cause damage to your DNA, which can be mutagenic, and something that's we often think of as a result of mutagens is cancer. So obviously that would be deadly if you are only one cell. So aerobic bacteria are able to make specific enzymes that turn hydrogen peroxide into harmless water. But aerobic bacteria don't have this capability. Excuse me, anaerobic bacteria don't have that capability. So we actually think anaerobes were actually one of the earliest forms of life on Earth. And whenever we had the great oxidation event, so whenever cyanobacteria, which are the greatest producers of oxygen on the planet, came into being, then it actually caused a lot of these anaerobes to have to find their own unique homes in the earth where there isn't oxygen. So, for example, deep in the soil. Which brings me to some extreme environments. So whenever we're talking about looking for life on other planets, and in this case Mars, one of the first things we need to do is try and test out our machinery, because it costs a lot of money to send stuff to Mars. So what scientists and astrobiologists use are Mars analog sites. And a lot of these sites are chosen for their topography. So they have a similar topography or surface as Mars does. So they'll be desert areas. So like in this left picture and this right picture, we have two different desert sites. And what astrobiologists will do is they'll also test out ways of sampling for life at these Mars analog sites. And what a lot of this life ends up being is some kind of, we call them extremophiles. So they're microorganisms that are able to live in extreme environments, like my microorganism on his extreme skateboard. Which brings us to actually taking that machinery to Mars. So the first thing I wanted to talk about was the Viking mission. So Viking 1 and 2 was part of the Mars exploration program. So they were launched in 1975. And part of the Viking lander mission was looking for biological organisms on Mars. And so this is a big fancy schematic, but all I really care about is the gas chromatograph. So a gas chromatograph uses combustion in order to tell what kind of gases are being released from materials. So we can use that, for example, to look for carbon. And what they found when they looked at untreated Martian soil was there was no significant concentration of the element carbon. So there were no significant concentrations of organic molecules. And that's really important because carbon is what we're all made of. So for example, an autotrophic organism is one that can make its own energy from like the sun. What a lot of people don't really think about is where the carbon in that plant comes from, because why would you? But the carbon in a plant comes from the gas carbon dioxide, CO2, and then that's actually what the plant is kind of made out of. So we use carbon to make sugars, or in the plant's case, starch, or cellulose, right? And then that actually gives the plant the plant structure. If you're a heterotroph, like a person or a moose, then you'll get your carbon from a different organism. So in the moose's case, it got its carbon from the autotrophic flower that it ate. And so finding carbon is really important because all the life that we've ever observed has to have carbon. So the other piece to this looking for life puzzle in the Viking lander mission was to use a labeled release experiment. So they took labeled carbon and treated some soil with it to see if that carbon would then be used to produce any kind of byproduct. So one of the byproducts that we're aware that anaerobic bacteria sometimes make is methane. So this is methanogenesis. It's really common in, for example, wetlands. So really hydrated soil is gonna not have very much oxygen dissolved in it. So we see a lot of anaerobic organisms there. So they were trying to see if they could measure any gases like methane or CO2 coming off of this treated soil that they had treated with some spiked carbon and nutrients. And they did see a spike the first time, and then the second time they didn't. And so this was really inconclusive, and it wasn't very clear why this result happened. Which brings us to the Phoenix lander mission. And the Phoenix lander, in some of its soil chemistry experiments, found that there was perchlorate in the soil. And that probably means nothing to you, and it meant nothing to me, but it's actually really important for those results. So perchlorate messes with how you can measure gases in a GC or gas chromatograph. So here I'm showing you a result of a paper that came out after we had those Phoenix lander mission results. And so the blue lines are the measurements they took from their gas chromatograph from some earth soil where they spiked it with perchlorate. And the red line is that same soil being tested without perchlorate. And you can see that that changes the results for carbon dioxide or CO2. It changes the results for nitrogen monoxide, NO, or for some of the more complex carbon molecules. So like C6H6 would be benzene. So it changes the way we measure these things. And so that raises more questions about what the results might have been like had we been expecting perchlorate in the Martian soil. Now, kind of back to our original question, we're asking if Martians are real. And we've sent a lot of technology to space to look for Martians. And all of these robots that we've sent into Mars's atmosphere and that have landed on Mars probably carried with them some microorganisms, so bacteria or archaea or fungi that were not readily visible. And our understanding of how to sterilize instruments has changed since the 1970s. And it's very possible that some of those organisms were on those pieces of tech. So are Martians real? Well, a Martian is a hypothetical or fictional inhabitant of Mars. And I'm going to tell you right now that I would hypothesize that there are Martians on Mars. So here is a result from the NASA rover Opportunity. So it took images from the Martian surface. And in the left panel, you see some white dots. So they're labeled 1, 2, 3, 4, 5, 6. And you see in the right image, those same dots, 1, 2, 3, 4, 5, 6. And it looks like those dots have gotten bigger. And it looks like there are more dots. These two images were taken 3 days apart. And the reason the one on the right is clearer is because they adjusted their cameras in the meantime. And the hypothesis here is, well, okay, this could be rocks, I guess, that the sand blew and revealed, except none of them got covered up. They all got bigger, and now there are more of them. So the other hypothesis is that these are fungal puffballs. So if you guys have ever seen an earth puffball, it's a type of fungus, it's a mushroom, where it's a big ball, and whenever you poke it, it goes poof, and then it releases fungal spores. So are Martians real? I think we have some fungal ones. So these are my references that I cited earlier in the presentation, and I have to thank these lovely people for working so hard on trying to find Martians. I'll clap for myself.
I'll clap for you too, and that will be the only sound that you're going to hear. I'm sure everyone else is giving you standing ovations right now from their living rooms in their pajamas. You'd see lots of pajamas and shorts right now if we were looking through the camera, which we probably don't want to be doing right now. All right, so I want to go first. So again, everyone, if you have any questions or comments, throw them there in the chat area and I will get them over to her. My first question is, and it was sort of answered a little bit in the last slide, but I want to hear, I guess, a longer answer about that, is that it seemed to me that for years or forever, as we talked about the search for alien life, that it was sort of the assumption that, well, alien life can only be supported if there is carbon and or water on another planet or asteroid or rock or wherever, just because that's how it is here. So has there been, are you aware of other discussions where that sort of if that's becoming a myth or something that people are looking into to think of exploring alien life, but not having to be based on either carbon or water?
That's a fantastic question. So, full disclosure, I am not an astrobiologist.
I know.
I am a geomicrobiologist, so I'm focused on life on Earth. So, the reason, I suppose, you might think of requiring water is that, so we need to stay hydrated in some way, but also, water is a chemical, right? And a chemical can be made from chemical reactions. And I was actually describing in the talk how bacteria can form water, right? By taking an enzyme and breaking down hydrogen peroxide. So it's very possible that even if there wasn't water on the planet, they may not need it. So this is actually fascinating. I don't know if you guys keep up with astrobiology, but there was just a paper that came out suggesting that there might be life on Venus because they measured, oh shoot, I should have written this down. I can't remember what they measured, but it's a byproduct of life on Earth, right?
Oh, phosphine?
Yes, phosphine. Thank you. But one of the arguments to that is Venus is really, really hot. And so just because phosphine is only biologically produced on Earth doesn't mean it has to be biologically produced on Venus. But kind of the same thing, just because we're not expecting life to make their own water on Earth doesn't mean that we might not expect them to make their own water on another planet. That being said, carbon is pretty important. But there are probably some workarounds to that, especially if we've been depositing carbon, right? So not every microbe that went may have made it, if that makes sense.
Sure, and well, that actually almost segues into another question that we have. This one is from Lauren, who's watching, and she mentioned the sort of poor cleaning of instruments. So is it confirmed that those fungal poof balls are probably native to Mars? Are they Martians, or could it just be bacteria that has run amok that we brought there ourselves?
So this is kind of a touchy subject, I think, among astrobiologists. Right, because
oh yeah, let's get in. Let's cause some trouble here.
Yeah, let's stir the pot. So, of course, no one wants to admit that they took bacteria to Mars. Like, no one wanted to admit that they don't have tardigrades on the moon, but it happened.
Sure.
So, there's, like I said, there's another theory that those are rocks. I don't know how much I personally buy that. It doesn't, I mean, really. There are some other pretty compelling photos if you want to look for them of what looks like microbial corrosion on some of the older rovers where they degraded really quickly. But again, Mars is a bit different than Earth, right? So something that may look biological from an Earth perspective may not look biological from a Mars perspective. So you really got to weigh that out for yourself, and there's no clear consensus. So actually,
Fair enough. Yeah, it's like a.
Oh, sorry. I was just going to say.
Yeah, I agree.
Really recent paper, so I'm going to keep interrupting.
Hey, I mean, if there is even a chance that there could be cheese puffs specifically on Mars, then I'm gonna sign up for that flight and leave my wife behind forever, just for unlimited cheese puffs. That would be delightful. I'm counting on it. Cool. All right. So thanks. That was delightful, and I think that's also sort of reminiscent of with the sort of black liquid spores and X-Files that were aliens as well. That didn't look like the intelligent life that we always assumed that they would be. Cool. All right. So with that, I'm going to give everyone the bonus of 3 minutes and say we're 3 minutes ahead of schedule here at part 3 of Nerd Nite Stream You in September, which means that Chequita, you can go ahead and disable your stuff, and Morgan and Laura, you can go ahead and say bye. Yeah,
Bye.
we're all leaving. And I don't want to. I'm not going to steal Laura's thunder here, but so why don't, as you introduced Nerd Nite Miami and Morgan, why don't you tell everyone the crazy thing that you just did? It's still, I have so many questions.
I think you're referring to the fact that I just flew on an airplane, which is mind-blowing, ran home, took a shower, got all the COVID off me, and now I'm here to introduce my sister.
I can still see some of the COVID. I think you got some in your teeth.
I tried, scrubbed really hard.
Right.
So, anyways, hi. May I start?
Yeah.
Excellent. Oh, okay, you're muted, so you're gone. Oh, bye, Matt. Okay, so hi everyone. My name is Laura. I'm one of 2 nerd bosses in Miami. In October, we'll be celebrating our 6-year anniversary. We host events the second Thursday of every month, and we switched to virtual. So if you need more Nerd Nite in your life, come join us in October, the second Thursday in October. I think it's the 10th. I don't really know. And tonight, I get to introduce our next speaker. Her name is Morgan Van Arsdall. She's a systems manager and anomaly response manager for the Hubble Space Telescope program. She's been with the Hubble missions operations and systems engineering team since 2001. More importantly, she is very awesome, always right, and a wonderful big sister. Please welcome Morgan Van Arsdall.
Thank you, Laura. You know there's some big sister bullying if she says I'm always right. So yay, Laura's the one that's always right in the family. So thank you so much for having me. I'm so excited to be here. This is actually my second Nerd Nite. I got to do a Nerd Nite Miami virtually also. So I guess that's the silver lining of all this virtual stuff, is that we can do it from anywhere. So I'm in Maryland. People are all over the place, so that's awesome. So hang on and I will share my screen and get started. There we go. All right. Holler if you can't see that. I'm assuming you can.
See it.
All right.
Yep, you can.
Awesome. So like Laura said, I am one of the engineers on the Hubble Space Telescope program. My current role is as the systems manager and also one of 4 anomaly response managers. So tonight I'm going to tell you a little bit about how we operate Hubble and what we do when there's a problem. And just to get the spoiler out of the way, sometimes we do just turn it off and turn it on again. Not the whole thing, but parts of it. So I'll start with the three questions that I get at least 50% of the time when somebody finds out I work on Hubble. First question I get most frequently, absolutely, hands down, is Hubble still really working? Is it really still out there? Yes, Hubble is still working. It is better than ever, quite literally. It's at the peak of its performance. So we'll start with just some fun facts as far as when Hubble started, some basics. We launched in April of 1990. Obviously, I wasn't working on the program at that time. And it was on spatial discovery. And you can see the picture there. Hubble looks a little bit different now. The solar arrays on the sides have been replaced since then, but still, basically, that's a pretty good image of what the telescope looks like. It's about the size of a Greyhound bus, about 44 feet. It weighs about as much as 2 elephants. Not weighs, for all I know, this is a really intense science nerdy group. So on Earth, it weighs about the size of 2 elephants. That's the mass it has in space. And it goes around the Earth once every 95 minutes or so. So we'll get that misconception out of the way. Hubble is not flying through the universe, right? It's just going around the Earth and pointing at things throughout the universe. So that's speeding around Earth about 17,000 miles an hour. So pretty speedy up there. Okay. So that's question number 1. Yes, it's still up there. And that kind of gives you an idea of what it looks like. Question number 2 I get all the time from older people, and I've only started realizing this. Millennials, Gen Zs that weren't around or conscious when Hubble was launched don't always know this backstory. But the question I get a lot is, isn't the mirror broken? No, it's fine. The optical system now is working fine. But when it was launched, the primary mirror, which you can see here, was ground ever so slightly too shallow, 2 microns too shallow. So that's a fraction of the width of a human hair. But it was shallow enough to make a difference. And so the initial images from Hubble were pretty fuzzy compared to what they expected. Unfortunately, Hubble was able to be serviced by the space shuttle. So on the first servicing mission, they put in some additional optics that meant that we could, that kind of basically uncorrected that. It was basically glasses, right? So the light was a little too shallow, and then it would hit another mirror, the CoStar optics, and be deflected back the other way. So that after that, all the images are the crystal clear, beautiful images that we're all really familiar with when we look at Hubble. Okay. And then finally, when will Hubble die? I don't know. I have no idea. We try not to predict the future too much. So the official rule, or the official line you'll hear, and general consensus is that Hubble will last until at least the late 2020s, hopefully beyond. So we're hoping we still have another 10 years or so, at least, which is pretty remarkable because the last servicing mission was in 2009. And when the astronauts left that in 2009, our design at that point, our requirements were that it would last 5 more years. And our goal was to last 10 more years. And we've obviously blown past that already. And that's what we're going to talk about today, is how do you keep this operating? We can't go fix anything anymore because the shuttle's not there. So how does Hubble work? How does it keep doing these amazing pictures? I'm not going to go through this in general, but again, this is kind of gives you an idea of how Hubble is built, right? And it's just like any other satellite, plus a telescope. So you still have the antennas and the solar arrays to give it power, and then all of the science instruments on there to actually take all the amazing images that we see. Okay. Here, because I know I'm talking to a group of nerds, and some of you might want to know what wavelengths we look at. This is a little bit outdated in that NICMOS down here isn't working anymore. So right now, Hubble always has been primarily a visible light telescope. And we go a little bit into the ultraviolet and a little bit into the infrared. But primarily Hubble observes in the visible light. Okay. What do we look at? I'm going to be talking about the engineering side because that's where I am. But the pictures are really the amazing things, right? And the science that we get is amazing. And we can look at anything from planets. We've taken lots of images of Mars and then further out planets, all the way to the furthest reaches of the universe, right? Galaxies, nebula, and then some pretty amazing just images of, we call them deep fields, right? Where you just kind of look into the universe and see all the galaxies and stars in that one little sliver. So Hubble can really run the gamut of things it can look at. What we cannot do is point towards the sun or point at Earth. I promise you, Hubble is not spying on you when you're at home in your pajamas trying to zoom into work. Hubble can't look at the Earth because it's just too bright. The bright Earth would overload the detectors. It's really primed to see things that are very dim and very distant. So we point to all these things. How does the data get down here? The light comes into the telescope. You can kind of follow this along, right? The antennas send it up to what we call TDRS, which is NASA's really main communication system. Then TDRS gets it down to White Sands. Those of you who are old like me will recognize White Sands from the movie Space Camp. That's where they landed, in White Sands, New Mexico. Then White Sands sends the data over to Goddard Space Flight Center, and that's where I work. And that's where we look at all the engineering telemetry, all the data that's coming down to let us know how it's operating. And then we send the science data up to the Space Telescope Science Institute, which is at Johns Hopkins. And they're the ones that process the science and make all these amazing Nobel Prize winning discoveries. So focusing in on Goddard now, this is the mission operations room. This is where the magic happens. Until 2011, this room was staffed 24 hours a day, 7 days a week, 365 days a year. And these people who you see here were members of the flight operations team. And we had flight operators sitting there all the time, making sure that the telemetry was fine, sending up commands. And then in 2011, we moved on to automated operations. And so now we all have our iPhones in our pocket that really helps us monitor the telescope. The flight ops team now works 9 to 5, Monday to Fridays. And if something goes wrong, if there's any data coming down from the telescope that's out of limits, right, so that isn't what we expect, the computer automatically sends us texts to our phones, and then we can respond and we can log in from home and see all the data. We can't command from home. The one thing that we still absolutely must be on site for is to send the commanding, to send actual, send things up to the telescope. And that's honestly more of a security limitation than a technology limitation. So automated ops has been a huge change in how we've operated. And it's really made our lives a lot easier, a lot more efficient, to be able to see, to be able to respond to things from home. And certainly for the flight controllers, the flight operations team, not having to work night shifts every few weeks really made a difference in their life too. So that was a pretty huge change in how we manage things. So we get a text at 3 in the morning because, like I said, one of my jobs is the anomaly response manager. So if there's a problem, my phone's going off at 3 in the morning. What do we do? And this is from very, very old, I think probably in response to the primary mirror old camera, but you can see, just install the new software. And that's pretty much what we do, right? We just install the new software. So what do we do when things go wrong? Hubble is an amazing piece of technology, groundbreaking in so many ways, and in so many ways, just like any technology that you have in your house, right? So if you have something at home that goes wrong, there's really 3 things you can do, right? You can fix it. And if you can fix it and start using it again, fantastic. If you can't fix it, you can find a replacement for it, right? And start using the replacement. If you can't fix it and you can't get a replacement, then you just have to figure out a way to go and live your life without it, right? And those are our same exact options that we have on the telescope. So fix it. That's the classic turn it off and turn it back on again. And in fact, we have a computer. The CUSDF is the Command Unit and Science Data Formatter. It's basically the science computer. We have 2 main computers on board, and the science computer after 2009 was replaced, and the replacement unit just sometimes freezes up, right? Just like your laptop occasionally locks up, this computer occasionally locks up. And just like your laptop, when you're having trouble with the computer, turn it off and turn it back on again. And sure enough, that fixes the problem. So sometimes it can be easy. We can turn things off, turn them back on again, and go on with life. The science computer this problem has happened enough that we've gotten really, really good at it. We can turn it off, turn it back on, and be back doing science in about 12 hours. The first time it happened, it took us several days because obviously we didn't know exactly what was going on first, right? And we had to understand really what was happening before we tried that. But now we can just turn it on, turn it off, and get back to science. Another good example of fixing it is our gyroscopes. Anybody that's familiar with Hubble knows that gyroscopes have sort of been the bane of our existence since they launched. Hubble needs 3 gyroscopes to point accurately, and that's really one of the amazing things about Hubble is how well it can point. When it has 3 working gyroscopes, we can use our normal controls, do everything like we plan to do. We have 6 on the telescope. We are down to 3. We have 3 that work right now. One of them, gyroscope 3, we turned on about a year and a half ago now. And when we turned it on, it turned out that it has this problem and that it has this shifting bias, right? So you can imagine really anything. If you have a measurement, right? If you have a scale at home and you know it's always 10 pounds heavy, that's actually not too much of a problem, right? You can still weigh everything and just take the 10 pounds away. That's fine. All the gyroscopes have a certain bias that we can take into account. Unfortunately, Gyro 3's bias shifts a lot. So imagine if you have that same scale at home and sometimes it's 10 pounds off and sometimes it's 2 pounds off and sometimes it's 25 pounds off. That's a real problem, right? So with Gyro 3, we needed to be able to sort of understand why this bias was changing and try to fix it, try to be able to address it at least a little bit. So again, we tried turning it on and turning it off. This time it didn't work so well. We still had the bias shift. So the next thing you do if your computer at home doesn't work really well is sometimes you just slap it, right? We've all slapped the TV on the side. We can't go up to the telescope and slap it. That's not very technical or engineering-y. However, we did slew the telescope. So effectively we moved it a little bit, right? We just made the gyro move a little bit and then move back. So the fancy words are that we slewed the telescope, but really what we did was kind of shake it around a little bit. And shaking it around actually helped. It got things back down. So just like at home, try turning things on and off again, try shaking things a little bit. Sometimes it works. We still have a lot of problems with that gyroscope, with that bias, but we've come up with several different software fixes so that we can react quickly to the bias change so that we're still able to operate with the gyroscope without any problems. So if you can fix it, that's awesome. If you can't fix it, sometimes you have to switch to the backup side. All of our science instruments and our main computers and the main communication tools all have backup sides. So sometimes we have had to actually just switch from side 1 to side 2. And that gets us going again, right? In the case of the science instruments, we would need to do a little bit of recalibration because they operate just ever so slightly differently. But for the most part, the things that we have backups, it can be a pretty smooth switch to the redundant side. So we have on occasion switched the science instruments. We haven't had to switch anything else, which is awesome. And then finally, if you can't fix it and you don't have a spare laying around, you just have to make do without it. And that's what we've been spending a lot of time lately preparing for. So like I said, we need 3 gyroscopes to operate in our original design. And we're down to 3, and there's no astronauts going back to the telescope. So now we have to figure out how to make do without it. And in fact, we have designed a new control law called One Gyro Science, where we'll be able to keep operating the telescope with just 1 gyroscope. We won't lose any science capability, any significant science capability. We will lose some efficiency. We won't be able to do some things all the time like we'd planned. Basically, when you can observe certain targets will be limited, but we'll still be able to do the amazing science with just 1 gyro. And that's a huge part of what the Hubble engineering team does right now, is we are really trying to think of all these things that could go wrong, that could break, the things that we're already on the redundant side for. How can we make do without it? How can we extend the life as much as possible with what we have on orbit? So 1 gyro science, we have used it on orbit. We've done some tests with it and it's worked, and we're really, really excited for it. Hopefully we don't have to use it for several more years, but we have it when it's ready. So that's pretty exciting. So that's kind of the basics of what we do when something goes wrong. So first thing is the computer detects that something isn't operating like we expect it to. Then it sends text messages out to the whole team, the technical specialists, and then people like me who are on the anomaly response team. And then we try to figure out what went wrong and either fix it, switch the backup side, or figure out a way to work around it. Okay. So that's super high level overview of how we operate the telescope. Like I said, I'm from the engineering side, not the science side, but I can't leave you without showing you some amazing Hubble pictures because that's what we do. So this April was our 30th anniversary. We were supposed to have all sorts of big parties. I was supposed to be able to go to the Air and Space Museum for a cool party. There were going to be astronauts there. It was going to be amazing. And then April 2020, we all know what that was like. So we didn't get to do any of that cool stuff, but the telescope doesn't know anything about coronavirus. So we did release this really cool 30th anniversary image of 2 nebula that are part of the Large Magellanic Cloud that are just, absolutely beautiful images. This one on my left is my personal favorite image. This is the Hubble Ultra Deep Field. Hubble has done a series of deep field images, and basically what it does is take a look at an otherwise dark piece of the sky. So you can see on the right side of the screen, the little tiny box that's marked XDF. That is what you're looking at on the left side. It was dark based on ground-based images. And you just point Hubble at it and you look at all the amazing things that are there. Almost all of the dots in this picture are galaxies, not stars. The only stars are the ones that have points. So you can see sort of a foreground star sort of towards the rightish of it. That's a star, but almost everything in there is dots and galaxies. So when you're talking about astrobiology and little green men and Martians, it's hard to look at this image and not assume that there are all sorts of life forms beyond whatever we could think about in here, and just how vast and full the universe is. It's pretty cool. Okay. And then finally, what comes next? The James Webb Space Telescope is the next to launch. Last I heard was late 2021 is what they're aiming for right now. We have a really big goal of being able to operate Hubble and James Webb at least 2 or 3 years overlapping, which, knock on wood, we should be able to. James Webb will be far infrared, so we'll be able to see even further back in the universe than Hubble has seen. And then after James Webb, the one that is currently in design and very initial construction is the Nancy Grace Roman Space Telescope. This used to be known as WFIRST, and then it was just recently renamed after Nancy Grace Roman, who is an amazing woman. She was really the grandmother of Hubble, kind of the first person to think about putting to get the real technical design as far as putting a telescope in space. So that telescope is, I think, the late 20s, early 30s is what they're aiming for to launch that. And so that's the future. If you want to know more about how we operate Hubble, nasa.gov/Hubble is a great site. If you want to see all the amazing pictures and learn more about the science, hubblesite.org is your go-to place for all sorts of images. All of it is publicly available, so you can download Hubble images and do, print them out, hang them up in your house, enjoy them. So I think that's all I got, and I would love to hear your questions.
Great. So Laura will get you the questions in a second. I just want to do one quick sort of plug for next week is that, so she has mentioned the Webb Telescope, and one of the operators of the Webb Telescope is also the boss of Nerd Nite Baltimore, and he's giving a presentation about that next Sunday, the 27th. So stick around for that as well. Just stay right here for 167 hours and you'll run into it.
And there we go. Perfect.
Great job. Okay, Laura, over to you.
Hi, Laura.
Hi. Excellent. Thank you so much, Morgan. Questions are coming in fast and furious. There was one early on. Why don't hang on, we gotta go back. Nick Moss. Why doesn't that work anymore?
Okay, that's a fun story. It was actually one of my very first jobs on Hubble was working on Nick Moss cooling system. So NICMOS is a near infrared camera, and it needs to be really, really cold to work. So when it was launched with a bunch of cryogenic material to keep the actual detector really, really cold. It got into space, and I wasn't around for the anomaly for this investigation for this, so I'm not exactly sure why, but I think because of launch forces. Part of the metal actually touched the cryogenic material, so it burned through that cold, the cold ice a lot faster than expected. So it wasn't able to stay cold for as long as we had hoped. During the servicing mission in 2003, we actually launched a cooling system to try to keep it cool, which worked for a few years, and then the cooling system wasn't able to restart. We did try turning it on and off at least 16 times. I was there for most of those. Didn't work. So sometimes turning it on and off works, sometimes it doesn't. So basically, we don't have any way to keep it cool, and a warm infrared detector doesn't do you much good.
Gotcha. Are the images colorized?
Good question.
Like,
sorry, I usually talk about that next year. Right. So basically, all of the cameras have filters, right? So filters for different wavelengths that are coming through. So those are the actual wavelengths filtering, whatever wavelength of color it is. Now, like I said, it's mostly a visible light telescope. So for any wavelengths within the visible light, the images you see are what you would truly see if you were looking out into the universe. We do some false color to get you the infrared and the ultraviolet, because we can't see those with our eyes. But so they are accurate. They're not they're not actual photos, right? So you're not seeing the color, but they are accurate to what you would see if you were looking out into space, which is amazing, right? I mean, those colors are amazing.
Yeah, it really is. There's everyone's just like, it's all those images are just mind-boggling, especially like the deep field ones.
Yeah. The deep field.
My dear friend Frank. Hey Frank. Shout out to Frank. What operating system and programming language does Hubble use?
Good question. A lot of different ones, sadly. So the new computer is a 486 that was built in, 1994, probably, something like that. So this is really old technology, right? It's not even 1990 technology, because it was built and designed way before that. We do software programming. So for the new software that we go up is in C, I think either C or C++, I'm not actually sure. We do have some computers that work on Fortran. And then there's also some binary stuff that we do. So it's kind of a mishmash of like 1970s technology and 2018 technology.
That's crazy.
Yeah.
A lot of interest in the James Webb, and would you or the same people be, I know the answer to this, but you can answer it in your words. Would the same people be working on James Webb when it launches?
Yeah, see, this is what happens when your sister asks a question and she knows I'm bitter about the answer. So no, it's a totally different group of people. Lockheed Martin is the contractor for Hubble. Northrop Grumman won the contract for James Webb. I do know some people, just people that had worked on Hubble that changed jobs and worked on James Webb. But from the engineering side, it's totally different. Now, from the science side, the Space Telescope Science Institute at Johns Hopkins, that team is the same. So the scientists that are running the science proposal part of it is the same between Hubble and James Webb, which is great because there's a lot of overlap there.
Oh boy. I haven't read this in its entirety, but I think I know where it's going. I heard recently, I think due to the Adiro issue, that a certain percentage of images reported back to requesting scientists are empty because Hubble is pointing in the wrong direction. Again, I know the answer to this, but I'll let you tackle this one.
Okay, yeah, so this is from the NPR News article that was just weird to me. Yeah, so every week, historically, every week between 0.5% and 1% of the images don't work for various reasons. Sometimes, like I said, the computer stops working, right? And we have to turn it on and turn it off again. Well, everyone that was planned, all the observations that were planned in that 12-hour period don't get done. That's unusual, right? That's like once a year. That doesn't happen a lot. But every week, say 1%-ish of the observations, we aren't pointing exactly where we think we are. What happens most typically is that Hubble will not be able to find the star that it's trying to lock onto, or find a different star that it thought was the right one, but it's not. And like I said, that gyroscope bias, it's changing. We're having to track that down a lot more frequently. So typically, historically, it's been about 0.5% to 1% every week. Doesn't get done successfully. Now we've been averaging more closer to, say, 3 or 4% every week. That changes obviously over time. But if you're a scientist and your science doesn't get done, we go to great lengths to redo it as quickly as possible. And sometimes when we know there's something really amazing, like when a comet was gonna impact Jupiter, right? That's a really big deal that we can't redo, right? So sometimes we will do observations in advance of that to plan it, to make sure that the stars align, to make sure we can point correctly. So there you go. Sound good?
The scientists need to be patient.
So the
and
scientists need to be
understand things.
patient. We'll get to it, I promise.
All right,
And
Matt,
probably
how
don't
are
go to Twitter for it.
doing on?
Yeah,
Maybe
you can.
don't go down.
We got
Have
time
his-
for a couple more. I got one for you, Morgan. I want to know where is the Hubble in relation to the Van Allen belts? There was a lot of Van Allen belt discussion last Sunday.
Oh, so the Hubble basically is in orbit generally around the equator. So we pass through the South Atlantic anomaly, but the Van Allen belts really aren't. You really don't interact with.
No, I'm good. I wanted to stay outside because I couldn't get a good signal.
Great. Ricardo, be
yes,
quiet.
Mute yourself.
There we go. So we go through the South Atlantic anomaly, which is a really weird part of the atmosphere where the atmosphere is a little bit higher than what it should be. And so we don't do science through that, but the Van Allen belts don't really don't come into our orbit at all.
Great. That's a good answer. All right. Was there anything else, Laura?
No, I don't think so.
Awesome.
How's your COVID feeling?
Awesome.
Yeah. Did you
So
shower?
far, so
You're
good.
clean, you're
You know,
good.
talk to me.
You're
Lots of
you're a
hand
daredevil.
sanitizer.
I'm actually curious. Everyone else watching along, if this is going to be a weird, not really a segue, but just how many of you have flown in the last, let's say, 2 months? I'd be very curious to see this.
It's just the Bracken sisters that are that.
I know.
You're so courageous.
It is. I don't know.
We have weird
Courageous. There you go. That's a good word.
Family issue.
Cool. All right, everyone. Give Morgan a big round of applause. Thank you for coming to us live from your living room. It looks very nice.
Thank you for having us.
And Laura, thanks for hustling back and washing the COVID off of you. Maybe that, I don't know. I'm very
Yes.
scared, but also optimistic. So I'm gonna try to lean towards
circle back
optimism.
in a week or two. And we'll...
All right. I'm wishing we're all pulling for you, just like we all pulled for Ferris Bueller. All right, Ricardo, Mr. D, go ahead and fire up your things there. Everyone,
Hi.
all right. My pleasure is always to hand it over to the good folks from Nerd Nite Orlando. Ricardo, the familiar face to many of you, of course, is the boss of Nerd Nite Orlando. And Derek, who's somewhere around here, he is a huge friend of Nerd Nite. He has presented many times. I'll let Ricardo do the proper introduction, but he's been a really good sport, good friend of us. He's presented virtually to our international groups. He's presented in person at some face-to-face national events. So Derek, it's always good to have you back. He's going to talk a little bit about how we can all look for some planets ourselves in the next few months. So Ricardo, over to you.
Hi, Matt. I'm doing good. How are you?
You're so smiley.
Can you hear me? Can you hear
Yes,
me?
affirmative. You're totally fine. You're a little choppy, but maybe you're just being a thespian and acting choppy. You're fine. Keep going. Plow right ahead.
Okay. All right. So yeah, I wanted to sit outside so I can get a better signal here. I kind of jumped the gun a little bit when the last speaker was talking. So sorry about that. All right. So I'm the host of Nerd Nite Orlando, and I'm really excited to bring on somebody that has been a part of our little group here down here in Orlando for about 7 years, and it's really amazing because he's actually one of our first speakers. So it's always nice to have him come back and do a great talk. And he is a very popular astrophotographer and astronomer. And obviously, for those stats, that the majority of his talks are going to be about space. So obviously, he was one of the first people I thought of when we put together this lineup. So without further ado, I'd like to welcome the famed astronomer and astrophotographer, Mr. Derek Demeter. Derek, take it away.
All right. Thank you, Ricardo. Hello, everybody. My name is Derek Demeter, Planetarium Director at the Emil Buehler Planetarium at Seminole State College in near Orlando, Florida. And I'm coming to you from outer space. You can see behind me, I'm in outer space because we are going to be exploring the planets that are currently up in the night sky. And we have something really cool tonight. We're actually going to be using some of our planetarium software that I have loaded up on another computer here. We're actually going to fly you to these planets. And we're going to talk about really briefly about these 3 distinct planets, do a little virtual exploration of them. And then I'm going to switch over to another software called Stellarium, and I'm going to show you how to find these objects in the night sky. So hopefully after the end of this Nerd Night extravaganza, if it's clear, here in Florida, it's been terrible. We have this depression running through, but hopefully if it's clear by you, you can go outside right after this program and look up and see these objects in the skies. So without further ado, I'm going to see if I can run my screen here. So we're going to start off here. We're going to be going in, as you can see, we are right over planet Earth here. So that's our home base. There we are in Florida right here. And you've got some other nerd nights all around the globe here. So let's go ahead and fly around the planet Earth here. We can see there's our beautiful planet from space. We can actually, because we talked about it just a minute ago. Oh, no, I don't have it turned on. I thought I did. Unless it's in, no, it's not. Normally we actually have the ability to turn on Hubble, but if this profile doesn't have Hubble in it, I'm sorry. I was hoping it'd be kind of cool to show off where Hubble is in its orbit and stuff like that, but maybe some other time. Well, what we're going to do now is we're going to go ahead and leave the Earth here, and we are going to fly to our first planet in the solar system. Yes, we are going to go ahead and visit the planet Mars. Of course, Mars is a big deal today. We just talked about that in the very first Nerd Night talk about is there life on Mars? That's a question David Bowie asked a long time ago as well. And since then, this whole life on Mars thing has been incredibly interesting. And of course, we just recently discovered potential evidence of the ingredients for life on Venus, which is really, really exciting. But Mars is a place where humanity wants to go next. Of course, we're building the infrastructure right now to go back to the moon, but the ultimate goal is to get astronauts to the red planet Mars. But right now, there is a little spacecraft on its way to Mars right now. It's Perseverance and Ingenuity. And Perseverance is going to be the next Mars laboratory, and it's going to be landing in the Jezero crater, which is located in just a place where we could potentially find fossils or evidence of life on Mars. So again, our first speaker earlier talked about, finding life on Mars. That's going to be a great location to potentially find life on Mars there. Now, what's really cool about Mars is a lot smaller than Earth, but it has some pretty large geological features. First one that's going to be noticed right here is we have what's called the Valles Marineris. And no, it's not made out of marinara sauce, but this is a large rift valley Billions of years ago, actually Mars was more Earth-like than it is today. It had plate tectonics, though the core of Mars actually shut off, so it no longer is active, no longer creating these massive plate tectonic shifts. It does have some seismic activity. The InSight, which is a spacecraft currently on Mars, is investigating that. But as far as these big cataclysmic events on Mars, that's pretty much done in the past. But this large canyon you see here was two areas of Mars's crust that were literally split apart. And at one time, there would have been water flowing through this Valles Marineris. In fact, these walls that you see here along the edges of the Valles Marineris are taller than Mount Everest. These cliff walls are over 5 miles high. And you could actually fit the state of Texas inside of here. Just to give you an idea of how big and enormous this canyon is. You can actually travel from New York City to Los Angeles, the distance of this canyon. But we also have some other evidence of ancient water on Mars. Not too far from the Valles Marineris is the Noctis Labyrinthus. This is called the Night Maze. And the Night Maze is an ancient, basically think of the Grand Canyon. You would have had water flow down this watershed, carving over time these various different canyons, similar to what we see obviously with the Grand Canyon. And over time, this would have been a plateau here, a highlands. The water would have flowed down and eventually make its way into that Valles Marineris, that Rift Valley there. So there would have been lots of water. This used to be an ancient lake, kind of like Lake Mead or Lake Powell, like we have in the Colorado Plateau. We even have large volcanoes on Mars. These are extinct large shield volcanoes, similar to what we see. And actually what I can do here is I can speed up time just a little bit so we can get a glimpse at the Olympus Mons. These shield volcanoes are similar to what we see with Hawaii, very slow flowing, big mounds of lava would have been spewing out of this. And with the lack of gravity on Mars, you could develop huge, massive volcanoes like the case with Olympus Mons here. Olympus Mons is a massive, massive volcano. You could fit the state of Florida inside of it, or the state of Arizona, or any pretty decently sized state. And the height of this volcano is about 60,000 feet. So if you were standing on top of this volcano, you would actually be above the Martian atmosphere, which is incredibly thin. Only a little bit of carbon dioxide in the atmosphere. So again, as you can see, Mars was a once very active, dynamic world that possibly had a very Earth-like environment and possibly could have had life. So we're still sending spacecraft out to Mars, like Perseverance, which will be arriving there in February. And who knows what we might find in the future. So that's the planet Mars. Again, we only have so much time, and I could spend a whole hour or 2 or 3 talking about Mars. We just don't have time for that. We're going to go ahead and make our trip over to our next planet in the Planetpalooza, and that, of course, is Jupiter. Yes, Jupiter, where people go to get stupider. No, okay, that's not true. That's stupid. Okay. We actually get smarter when we go to Jupiter, because as we send more missions to Jupiter, we learn that this planet is incredibly interesting. This planet is this massive hydrogen ball that, if it were 10 to 15 times larger or 100 times larger, could have very likely been a very small star, maybe a red dwarf or something like that. Or if it was a little smaller, it would be more classified as a brown dwarf. But this thing is massive. You could fit over 1,000 Earths inside Jupiter. And Jupiter, even though it's very massive, its density is a lot less than Earth, because it's mostly made up of very light material like hydrogen and helium. And it actually only has a rotation, a daily rotation, in under 10 hours. So if you were to actually look at Jupiter through a telescope over the course of several hours, you would actually see the rotation of Jupiter. You can actually see the planet rotate. And not only that, you'd be able to see the moons, many of the moons called the Galilean moons, named after Galileo, the one that he was the first one to actually see these moons through a telescope. 4 distinct moons. You would actually see them moving around, orbiting around Jupiter. And that's, of course, what eventually kind of changed our perspective of the universe, or in this case, the solar system. Now, since Jupiter rotates very quickly, these various different layers of clouds that we see in the atmosphere of Jupiter, they're swirling around at different velocities, and they create these huge, massive Coriolis effects. Basically, this swirling of and almost kind of like little eddies, little swirls and whirls. And one of these large weather systems is what we call the Great Red Spot. Now, I might have to, I have to spin the planet around. So let me go ahead and do that now. So I'm going to go ahead and spin the planet around until we get the Great Red Spot visible. There it is. Great Red Spot is one of the coolest features on Jupiter. That's because Jupiter has this massive object. It's about the size of Earth, and it's not a hurricane. It's actually a high pressure system that actually the winds are actually strongest on the outside, and it's actually very, very calm where we would imagine this storm would be actually producing, the winds similar to a hurricane. But the winds near the Great Red Spot can get up to 450 miles an hour. So when you think of a hurricane on Earth and the massive winds that are produced from that, that's pretty crazy. And just imagine an Earth-sized weather system with 450 mile an hour winds. That's pretty intense there. And you can actually see the Great Red Spot from here with a telescope. And if you pick the time right, you can actually see the Great Red Spot yourself. Now, we don't have time to take a look at all the moons of Jupiter, but I want to talk about one of the moons of Jupiter that's really cool, Europa. And Europa is really exciting because a lot of it contains water. In fact, there's more water on Europa than all of Earth, and it's a lot smaller. And most of its crust is made up of water, and it's also a silica-rich one. So, hey, there could potentially be life there as well, just like we find here on Earth. And so eventually the hope is to go to Europa, drill through the ice, make our way down to this liquid ocean underneath the crust of Europa, and we may potentially find life. That would be pretty cool. So again, we're working on missions. Other countries around the world are working on missions. Hopefully one day we will find life in another place in our solar system. And our last place we're going to visit is Saturn. Now, when everybody thinks of a planet, probably you're thinking of a ball with a ring around it. And that's because Saturn is in many times is one of the recognizable planets in the solar system. And generally, I actually have a voice message on my phone, which I'm not using at the moment, but I usually ask people their favorite planet, and they pretty much say Saturn because of the rings, or Earth because we live there. Or you get that one person every once in a while that gets really sassy and talks about Pluto and how annoyed they are that Pluto is not a planet anymore. But that's a whole nother subject too. I think I did a program on that a while ago. Maybe I could do it again. But here we have Saturn, and actually right now, this is actually the path of Cassini. I'm going to go ahead and turn that off there. And here we have Saturn. Lovely, lovely, lovely Saturn there. And of course, as you can see, we see these lovely rings. But those rings are actually not solid. They're actually made of all these tiny little pieces of ice and rock. So if we were able to actually fly through the rings of Saturn, which we can't do in this particular profile, unfortunately, I'm using a substitute. I have another laptop that runs our official program, but unfortunately, it's being serviced right now. So unfortunately, I don't have the ability to fly into the rings, but there are, this program does allow me to go in the rings, which is really cool. But if we were flying to the rings of Saturn, you're going to see billions of tiny little chunks, about the size of a school bus or a bus, of ice and rock. And we think those rings formed from moon formations that got really close to the planet Saturn. We call it the Roche limit, and it basically just ripped them all apart. Collisions, debris that's been flying around the solar system that got picked up by the gravity of Saturn. So all this mix of stuff eventually formed the rings of Saturn. But it does have a shelf life. The rings of Saturn are believed to only last for another 300 million years. So aren't we fortunate to be around at a time when we can see the rings of Saturn, which is pretty cool. But it does rain ring material into the atmosphere of Saturn. Imagine flying into the Saturn's atmosphere and seeing particles of ice and rock being pulled in. Now, Saturn also has moons as well. Titan is another one, really exciting moon, another place for potential life. It has an atmosphere of organic molecules. It has hydrocarbon lakes, ethane and methane and all these different other hydrocarbons. And it's very possible there could be life there, which is which again, so who knows? You know, in another 100 years, we may find a lot of life, or we may not. It could be the case. But Saturn is another great place to look at. And so what I'm going to do now is I'm going to go ahead and stop sharing for a hot second, and I'm going to switch over to another program called Stellarium. Now you can actually download this software for free on your tablet, on your laptop, desktop, or even your phone. Stellarium, and it's spelled with an S, so Stellarium. And you can actually download this and use this software to look at what's currently in the night sky and all that. Now, as you can see here, we have September 20th, and the time is 10:40. We wanted to make it in a way that this is Eastern time, so if you're on the West Coast or somewhere else around the world, you want to go out around this time, your local time. But this is 10:40 Eastern time, or local time for you. And what you're going to notice is if you're actually under a really dark sky, if you're away from all the city lights, you'll actually see this very extremely bright object here. This is the Milky Way. It's actually not that extremely bright if you're not in a dark sky. If you're in the city, well, like Matt in New York City, you're not going to see anything. You know, because of the light pollution. But this is the Milky Way. This is a band of billions of stars seen in the densest areas of our Milky Way. But if you look towards the southwest this evening, you're going to see two bright objects, two bright stars. Now, how to differentiate a star from a planet is if you look at stars, you'll notice they flicker or twinkle. You remember the old twinkle, twinkle, little star thing, right? Well, we're going to use that to find planets. A planet doesn't twinkle like a star will, or it doesn't twinkle enough to really notice. Unless the atmosphere is really, really turbulent, sometimes the planets will twinkle. But on most occasions, the planets will be nice, bright, solid objects in the sky. And the brightest of all of them up in the sky is the planet Jupiter. So Jupiter is going to be the one furthest towards the southwest. It's going to be the brightest of the two. You got Jupiter here, and just to the left of it, above it there, is Saturn. So you'll be able to see Jupiter and Saturn pretty much right next to each other in the sky. And so hopefully you'll be able to go outside after this program or next day or two and go out and take a look at these objects in the sky. You'll actually see other planets. Now, if we go over here to, let me go ahead and get rid of that. Go away. If we go over to the to the east, if we go over to the east, just above the horizon, basically the horizon's where the sky and the land meet. Just above the horizon, you'll see a very brightish red star that doesn't twinkle as well. And that, of course, is the planet Mars. Now, what's exciting going on? Mars is reaching what we call opposition. The planet Mars is actually getting close to Earth, about 60 to 70 million miles or so away from us. And being that much closer to Earth makes it brighter and makes it better to look at through a telescope. Now, Jupiter and Saturn always look really well through a telescope. Again, you'll see the gray red spot on Jupiter. You'll see the moons of Jupiter. You'll see the rings of Saturn. But Mars, generally, he looks like a tiny little red dot. But when we reach opposition, well, Mars looks really, really good through a telescope. And unfortunately, I would have been able to show you some cool pictures of Mars, but we've been rained out for weeks here in Florida, and I haven't got a chance to really get a good view of Mars lately. But hopefully that will change soon. Hopefully I'll be able to get some clearer skies. And on October 9th, we are going to be doing, starting at 8 p.m. Eastern Time on the Planetarium's Facebook page, we're going to be doing a live virtual star party observing the planet Mars, Saturn, and Jupiter. So if you're interested in this stuff, you don't have a telescope you want to look at, we'll have these really cool, powerful telescopes to show you the planets. So this is a really exciting thing to look forward to. But if you have a telescope at home, definitely take it out. This is a really great time. You know, even we're trying to social distance, we're trying to stay at home. Astronomy is a great thing to do. If you have a clear backyard, if you have an area nearby that's open, take your telescope out and look at the planets. And hopefully this program, hopefully my little spiel tonight has inspired you to do that, and maybe even just buy a telescope or a pair of binoculars and look up in the sky and be amazed. So again, I want to thank all of you for allowing me to come on here and talk a few moments about the planets, and keep looking up, and hopefully you get to see some cool stuff. Thank you, everybody.
All right.
All right.
So, sorry, Ricardo, let me ask one question first.
Oh, yeah,
before
of
I pass
course.
it over to you and to all the viewers. So, Derek, you mentioned, and I've seen it, but if you could spoil it a little bit for everybody watching, can you give a 10-second cliff notes on your "Is Pluto a planet or not a planet" presentation?
Depends on who you talk to, but see, the word planet has evolved over the years, and the planet is very broad. Think of like the word mammal, and we have now terrestrial planets. We have gas planets, ice planets, and things like that. And Pluto is now a dwarf planet because its path hasn't been cleared of space junk and whatnot. But technically, dwarf planets are planets too in the grand scheme of things. So we're trying to get away from this idea that there are 8 major planets and dwarf planets. We're saying that there's 4 terrestrial planets in our solar system. There's 2 gas planets like Jupiter, Saturn, 2 ice giants, Uranus and Neptune, and 5 dwarf planets. Pluto, Eris, Sirius, Haumea, and Maki Maki.
That is, I didn't know that. Wow.
Now you know.
I thought you said mahi mahi. That's why I was laughing so hard, by the way. So let me jump into a question here. Someone says, why are Saturn's rings on the same plane?
Yeah, so think of you probably remember, those gravity wells that you see, like the gravity wells, like the thing where you throw the penny in there, and there's a plane think of gravity as a well, and the center of mass of Saturn is kind of where the center of gravity is. So everything as it gets kind of tumbled around in gravity of Saturn kind of creates that fall effect around the planet. So if things get knocked around, eventually what's going to happen is they're just going to create this kind of angular momentum that's going to be pushing it towards around and creating this just nice plane in around the planet. So again, that gravity well, the way gravity essentially pulls things around the center of mass creates that kind of plane of the orbital plane. That's why our solar system, for the most part, is in a very flat plane. I mean, relatively. There's a little bit of change, but except for Pluto. Pluto's kind of weird. But Pluto's really small and it's very.
Wait, did you say that it's flat? That's a tricky word.
Well, not flat. It's not flat because obviously there's 3-dimensional, but it's very. If you look at it from a grand scheme of thing, there's a plane. It's in a plane. It's in a.
Someone's gonna cut up this video.
Yeah, I know.
The astronomer Derek Demeter said it's flat.
It is not flat. Okay, yes, Earth is not flat either. So you heard it from me. The Earth is not flat.
So we have another question from our buddy Ed Peterson. He says, "Where did you get that awesome outfit?"
Ed. Yes, Ed is he win the award for like the person that attended most Nerd Nite Orlando. Yes. Thank you, Ed. Thank you for attending. I got this actually. I think at a Spirit Halloween. Yeah. So there you go. I'm not endorsed by Spirit Halloween. This is not a legit like flight suit, but we are actually working on getting like actual real flight, like realish flight suits. We can't get official ones, but that the astronauts are, but ones that are you would see if you went to Kennedy Space Center Visitor Center. So, but this is the next best thing, right? So yeah, I got this at Spirit Halloween. So check them out. You can get one too.
I have a question for you. You mentioned earlier, that maybe in 100 years, maybe there's we find some life on Titan. Do you ever see a point where there are like stations where people are like actually living on Titan? Is that possible?
So, one of my favorite facts about Titan is because of the lack of gravity, but the density of the atmosphere is you can technically fly around like birds on Titan. So can you imagine people just like gliding around, like flapping their wings, like in a bird knot suit? So technically, if we could develop habitats, yes, we could develop habitats on Titan. Most likely, it's going to be done at first with drones. Right now, we're actually sending Dragonfly to Titan, which is a little drone. Eventually, there's going to be blimps and airships because it's just easier to do it that way. But yeah, I mean, maybe not 100 years. I think I'm a little bit more realistic because I think just how slow the space program goes. But I would say that in time, there's no reason why we'll get to that point where we will colonize or we will find ourselves in deeper space, we will land on Titan or Europa or something like that. So it's entirely possible.
Do you think that
I'm sorry,
like
Derek, can you say that one more time? That was based on the atmosphere and the density of the planet. What were the two factors for that?
So yeah, so it's a lot less gravity than Earth, but there's a lot of atmosphere on Titan, a lot of atmosphere. So you'd have enough lift because you would weigh a lot less. You'd actually weigh kind of like a bird on Titan. So lack of gravitational pull on you, plus the density of the atmosphere can create enough lift for you to actually fly around like a bird on Titan. So,
do you think that the private space industry, like companies like SpaceX, are driving that timeline faster, or is it like government, like NASA's driving it faster?
I mean, yeah, I mean, obviously commercial organizations can go faster because there's a lot of, bureaucracy in the government that kind of, things have to be done a certain way and have to be checked off by X, Y, and Z. Commercial organizations can be like, we want to get this done, want to get it done now. So yeah, I definitely think that we've seen with SpaceX and now at Blue Origin and other organizations, it's going to be quick with them. I mean, I think it's only going to be a matter of time before they get to Mars before NASA does. But we'll see. Or the hope is like with Artemis. The hope is that they're going to come together and NASA won't be this building all this stuff or contracting just United Launch Alliance, Boeing and all, and they'll be working all together to hasten it. So maybe the idea is that eventually these companies will all come together to work together, but who knows, but I could say that, with what we've seen with SpaceX, I mean, this is pretty incredible. Crew 1 coming up here later on, and it's going to be exciting, to see what's in store for the next decade or so.
Now, I have one final question for you. Obviously, finding the potential of life, evidence of life for Venus. Do you see any other big announcements coming soon? Like, is that just getting people's our neurons just firing off in the heads of every single astronomer, and they're like, I knew it. Like, what's next? What's the next big thing that's going to happen? I could predict.
I really think if Perseverance can find fossils or any other evidence or something that was produced through life on Mars, I think that's going to be the next exciting thing when it comes to that kind of stuff. Because Perseverance is really going there to look and take samples of material that would have been produced from a life entity on that planet. I think that's going to be, in my opinion, I think it's going to be a really exciting thing to actually, and eventually they're going to bring those samples back to Earth, hopefully by 2026. They're going to go back and they're going to pick up those samples that are left in these tubes that Perseverance will collect, and they'll bring them back to Earth and we'll be able to study them. So I think that's going to be really like one of the coolest things that we're gonna see come up very soon.
Well, thank you so much, Derek. I gotta say, as Ed pointed out on Facebook, I totally miss Nerd Night, and obviously you've been a mainstay of that since for the last 7 years here in Orlando. So thank you for speaking tonight. And this is very nostalgic to hear you. Having you talk about space is like part of the Nerd Night experience here in Orlando. So thank you for your talk.
Well, I miss it too. I miss getting together with everybody, and hopefully we'll get to do that again soon. But hey. Yeah. It's always a pleasure. So thank you, everybody.
All right. Take care, Derek. Thank you so much.
Thank you, Ricardo.
Right, back to you, Matt.
Take care, everybody.
Thanks, Derek. Again, yeah, thanks as always. Yeah, everyone. Just like Ricardo said, Derek has been a huge asset and fan and supporter presenting at Nerd Night all over the world. So thanks as always, Derek, for the great stuff. All right. So Kasha, over to you. You can go ahead and turn on your mic and webcam there. So we're gonna end things on a little bit of a lighter note tonight than we did last week. Kasha is not only a writer for NASA, but she also is a stand-up comedian, and she's going to talk a little bit about the science of science comedy. And so I want to use this for my 60-second introduction here. And she comes to us from Nerd Night DC. I've been developing for many months the ultimate stand-up, mini stand-up routine. So Kasha, here's my 60 to 90 seconds here. I'm gonna try this out on you and everyone else, and you got to tell me what you think.
Oh boy.
And if it's bad, then you don't have to tell me at all. All right, so here we go. So, heaven. It's supposed to be, it's people up in the sky on white fluffy cloud. And this is my space segue also. So, heaven. It's up in the sky, or everyone's looking down fondly on Earth on their white fluffy clouds. But what happens to the people who have just died, who were afraid of heights when they were alive? Did they suddenly die and then wake up in heaven and they look down like, oh my God, and they're terrified, and they think they've gone to hell because they're so scared because they're afraid of heights and they're terrified looking at Earth down below? Or does that explain what fog is? And fog is just the people who are in heaven but are afraid of heights, but that way they're much closer to the ground, and that way they can feel better. How is that?
I like it. You have a lot of really good elements in there that a lot of stand-up comedians use. Like, you had the characters in there, you had the alternate explanations. I think make it ready for a prime time in another, well, I guess your next Nerd Nights in a week. So yeah, I think that could be stage ready. I think so.
All right, I'm going to go back to the drawing board. I'm going to make up some notes, and I'm going to touch it up a little bit. All right.
Yeah,
thank you for the wonderful constructive feedback. Now let's hear what we really need to know.
Yeah, and after listening to my talk, maybe you'll pick up a few things about what is comedy, which is always an interesting thing to talk about because there are always so many different opinions. First off, though, I just want to say I'm so excited to be looking at my computer right now and to you guys. This is so exciting for you. But these speakers have been absolutely wonderful. I see a lot of my colleagues are there. I've never met you, but we all work at this small startup called NASA. And I just think that's so cool that you guys are here. You probably have a lot of these issues that I do. You always have to be careful about how you explain where you work, right? So I guess if you want to be truthful or impress somebody, you say you work at NASA. If you want to bore people, like I say I work for the government. If I don't want any follow-up questions, I say I work for a travel agency. So it just kind of depends on how much I like that person, depending on what answer I give them. I love this. I love the talks today. We started out with a kind of a chemistry vibe thing, which I studied chemistry. So I always love meeting another chemist because there's always an immediate bond there. I like Morgan talking about Hubble. I also am in Maryland, or work in Maryland. Used to work in Maryland. One day we'll work in Maryland again. So maybe we ate lunch in the same building at one time. And then Derek just showing us all these baller models and images and stuff. That was so cool. And I like how you kind of told us a little bit about what a planet is. And we did discuss, I think everyone discussed life on another planet. And that just makes me laugh so much because I remember an article that I read in the New York Times many, many years ago, when Kepler was making all these exoplanet discoveries about possible planets that could have life. And I remember in New York Times, it was a headline actually, and the scientist was saying, scientist says there's life on another planet. And then you read it and the scientist is saying yeah, I mean, there's bound to be life on another planet. We just haven't found it yet. But probability speaking, there is. And to me, I read through that. I'm did this scientist just go through a breakup or something where he's oh, there is we'll find another Jennifer. I mean, Earth, we just haven't found it yet. It just, to me, it kind of feels like searching for life on another planet is a lot like searching for love. So hopefully there will be a happy ending for everyone who wants one. My name is Kasha. It is a foreign name. And I always think foreign names always have the prettiest meanings. Like my mom's name is Shobha, which literally means beauty. My brother's name is Kavi, which means poet. I found out that my name, Kasha, also has a meaning. It is a type of buckwheat. Thank you. Thank you. My ex-boyfriend actually found that out and he had to break up with me. He was gluten-free. I actually remember, though, I talked to an astronaut, and the astronaut told me that Kasha is what poor people eat in Russia. Cool. Thank you for that piece of information. I'm particularly excited to be here at Nerd Night. I performed here maybe like once or twice before. I can't remember, maybe 3 times, who knows. But I always feel like I really bond with the people here because I was a nerd like my entire life. I could tell I was a nerd because I never had to say no to drugs growing up because I was never offered any. I remember when I went to college, I wanted to change my image though and become really cool. So I did something that all the cool kids did. I played a sport. I played ultimate frisbee. Yeah, I played the position of treasurer. Thank you. I did very well in Excel. I work as a science writer, actually. So a lot of the things that we heard today, I've like vaguely knew about, or I wrote an article about. Like Derek talked about Perseverance landing in Jezero crater. I actually wrote an article about how we study places on Earth that are a lot like that area. Particularly, there's a lake in Turkey called Lake Salda, which is pretty similar in certain features of Jezero crater, especially the delta feature of that, which was extremely cool to write about and learn about. But I like my job as a science writer because every day and all day I'm always talking to scientists and learning new things. Like I learned that astrophysicists are very good spellers because they're constantly spelling all these really long, complicated words like heliopause, spectroscopy, insufficient funding. Part of my job is I actually have to read studies all day and every day. I also like to do that in my personal life. I actually saw an article the other day. It was a study that said men are funnier than women, but it was written by a man. So I just thought he was joking the entire time. I'm like, oh yes, this abstract is hilarious. Yeah, this is fantastic. I do think that NASA is really cool for so many reasons. One of them being, we were the first ones on the moon, which is really cool. Scientists actually estimate that those footprints will last on the moon for about, 1,000,000 years, which is incredible. That is the longest example of a man not cleaning up after himself. So that's so special. I actually work in the Earth Science department. So while all the other telescopes are looking out, I'm looking at the ones that are looking back in. And it's always interesting to think about, our systems here on Earth because we actually know a lot more about, let's say, the surface of Mars or the moon than we do about, the whole ocean floor and what actually lives down there. Like to me, it's just so crazy how much we don't know about the ocean. We know more about Cardi B than we do the ocean. Like we know where she mates, what she ate that day, how many babies she had that year. Like scientists would love to have that kind of information about sharks. I did read a study the other day, though, that said people are less afraid of hurricanes named after females, which is bonkers to think, this year, especially with our very active hurricane season. But I think that they're just not naming these hurricanes correctly, right? Because females can be so scary. They're just not naming them correctly. Like if you had a hurricane named Serena Williams's arms, people would be freaking out. And if you really want people to run away and seek shelter, just name it Jehovah's Witness knocking on your door. It works every time. We do have a lot of really cool launches happening. And a lot of them, I mean, it's incredible the amount of success that we're having them. Derek mentioned about the SpaceX and how we're actually able to launch astronauts off of American soil. That's so wonderful. I do remember a few years ago when we were still kind of in the process of doing this, SpaceX actually had a launch, but it exploded when it left Earth's atmosphere. It actually disintegrated. But NASA did not call it a failure. They called it a non-nominal launch, which is weird because last week I had a non-nominal date. Yeah. I will leave you guys on this. I think that NASA, people often like to talk to me a lot about NASA. And that's why I'm glad all these other NASA experts are here. So like they can answer all the hard questions and I can just be like answering silly questions about comedy. But I just think to me, NASA is a lot like church because we're both trying to find a better place to leave after Earth. So All right, guys, that was just a little bit of my science comedy routine that I do. Some of those jokes are new since quarantine, so they actually haven't been tested out that well. And some of them are some of my favorite jokes. But what I want to talk to you about is, I do these jokes every day. And well, before quarantine, I would do these jokes anytime from like 4 to 11 times a week. I would be going out and doing comedy live. And it was incredible. You get a lot of data from that. I have my science jokes and I have my non-science jokes. And when you have that much data, and maybe this is the nerd part of me that many of you guys will be able to relate with, you just get very excited and you want to look at trends. So I've been doing comedy for about 7, 8 years, and I've really been entrenched in, how to write a joke. Okay, can we do this science themed? What are the takeaways? Is the audience actually responding to it? And I should say that my entrance into science themed comedy is a little interesting because I don't know how many of you actually have ever heard of science comedy before. 8 years ago, I never heard of it. When I started stand-up comedy, I actually tried doing stand-up science-themed jokes because I was studying for my science journalism degree in Boston, and it just made sense to me. I loved science. I was around it all the time. I was reading all this news about science. So I thought, wouldn't it be great if I could do science-themed comedy? So I actually started writing science jokes, and I would test them out at open mics in Boston. And the group that you get in Boston at a bar on a Tuesday night, let's just say it's not necessarily like the future Nobel laureates. It's like the Boston townies. And I think their tolerance for science jokes were a little lower than, what I expected for being like a big Boston educated city. And also I sucked. When you start anything, you're terrible. So my jokes weren't very good either. And for those reasons, my jokes didn't work that well. My science jokes didn't work. I even got heckled a few times. And I just kind of stopped. I was like, okay, you know what? Maybe people don't want to hear science jokes. So I stopped. And when I came to Washington, D.C. for my job at NASA, I actually had my colleagues, they found out that I did stand-up comedy and they said, oh, that's cool. Do you do science jokes? And I was like, oh, you would come to a show with science jokes? And they're like, yeah. So I actually put on my first science-themed comedy show in Washington, D.C. And I made it free because I was like, I don't know who's going to come. And a surprising number of people came. I was very impressed. And I did another one later. I did a donation, people donated, and more people came. And then I kept putting them on, and I had to turn a lot of people away. And we're talking about 100, 200 people at times. The shows did very well. And one piece of criticism that I got was I would always send surveys after the show, which I highly recommend to people. Swallow your pride, send out the survey. It really improves whatever you're trying to do, whether you want feedback on how you're presenting something, whether you want to improve your event, whether you want to improve the venue that you're at, all of those things. Sometimes people can be kind of mean because they're anonymous, but I mean, it is really helpful, and you just have to have a tough skin and pick out the constructive criticism from it. But one of the criticisms that I got was that I was doing the same jokes from the first night to the second night. And these were maybe a month or two apart. And the ability to write a tight 5 minutes that quickly is very difficult, especially when you have an audience that isn't science minded all the time. Like I said, I'm going out 4 to 11 times a week. So I'm doing jokes in front of whoever decides to show up on that Friday night, on that Monday night. And then I'm working at comedy clubs, and they're not science comedy audiences exclusively. So I really kind of had to change the way that I wrote my jokes. And what I noticed was that if I can make a non-science audience laugh about science, the science audience will laugh. If I write a joke that the science audience laughs at, not necessarily the non-science audience laughs. So my new target when I went out for all those open mics was to write science jokes and do it for whoever I could get in the audience and to make them laugh. So for the past 8 years, that's what I've been doing. So I want to share my screen and talk to you about what I've learned, as well as some other really cool research that I have stumbled across. All right. Great. So this is the science of science comedy. So like I said, I did Washington, D.C. shows of science comedy. The very clever name was DC Science Comedy as a comedy production company. And this is an example of one of the bars that I would do it in. Because I also, I have to fill out an hour and a half long show, and it couldn't just be me doing stand-up, and there aren't a lot of science comedians out there. I also had to get pretty creative of how to fill up that time and make it informative, science-related, and funny. So the second picture here is actually a scientist mining out their research with a comedian commentating over it. And the comedian didn't know what the scientist did. And the comedian wasn't necessarily trying to guess. It wasn't like charades. They were just, what was that scientist miming out? And they were just saying what came to their mind. So it was kind of like a fun science communication exercise where it's like, okay, this is how people perceive what you're doing. And it also got the scientists to do some silly things. This is me at one of the major comedy clubs in DC, which was extremely cool because my headliners, I've been very lucky because our audiences really like it. So I'm able to actually bring in headliners from, Netflix, Comedy Central, all these other science channels. And I even actually got a politician. Like I said, this was a few years ago when he was like one of two scientists in the government or in Congress. And that was really cool. He came up and he did a little routine. So that was very exciting. Now that we're in quarantine, obviously those things are a little harder. I have been doing some virtual shows and they have been on YouTube. I started a new series called Fact Checking Space Force, the TV show, not the agency, because no thank you. And it's been a lot of fun. So yeah, I have a lot of videos I've been doing on YouTube. So if you want more YouTube stuff to watch, you can. And also I live stream all my virtual shows there. So you can kind of see how it's adapted. Now, I talked to you about, I do these shows all the time before quarantine, and I'm collecting the data. I record all of my sets. And I actually wanted to analyze my data and see, okay, do my science jokes work better? So this is actually an example of an Excel sheet that I use. And I found out that science jokes actually performed better and overall versus my non-science jokes. And what I did was I actually measured the number of seconds it took to say the premise versus the amount of laughter that followed afterwards. So we kind of get this efficiency ratio. And I also separated it by set. Okay, did it matter where the science joke was? I separated my set into quarters and I found out that it didn't matter. Wherever my science joke was, it worked better. Now, I presented this in a TEDx talk, and it's on my YouTube, it's pinned to my Twitter profile and everything. So I highly recommend if you're interested in learning more, follow me or even just, go to my social media. And I'm also, all the links that I'm talking about here, I'll be tweeting them all afterwards. So you can kind of you don't have to go searching for everything that I just said. And in my TEDx talk, I actually give a couple of reasons why I think this happened. And one of them was I think that my jokes had a level of truth to them. Science, I'm giving out exciting information, new information. I think people were very excited about that. So that's one aspect. And I highly encourage you to watch it. But what I want to talk about is okay, what are some, does science comedy actually work? And what I found is like, okay, yeah, people do like science themed jokes. But before we go into the next actual research that I've come about, I want to step back and talk about what is a joke. And this is where, Matt, it was great that he gave us a joke up top. And now you can all learn, did he follow this format? Not like there's jokes can take any form. You don't need a formula to do it. But what is a joke? It's in two parts. First, it's serious. And this is Chris Rock.
A lot of comedians have great jokes and they don't like, why isn't this working? It's not working because the audience does not understand the premise.
That's right.
So I just like, I'm going to make sure if I set this premise up right, this joke will always work. But if I kind of go namby-pamby about setting up the premise.
So hopefully you guys, that didn't stutter, you could see that it didn't buffer. But that was Chris Rock talking about the most important part of the joke is the premise, not the punchline. Because if the audience doesn't understand what you're saying, then it's not going to work. And then once you figure that out and you really get it down, and for science jokes, it's actually interesting because my science premises are actually longer than my non-science jokes, just because there's more explanation that I need to do there. And because I'm a science writer, those skills actually overlap a lot. When I write my science premise, it's actually a lot like a headline that I'm writing for one of my articles or a summary statement for one of my articles. So in that way, that's kind of how I view it, and that really helps. Once you figure out your premise, you can make it funny with a punchline. Now, there are several different ways you can make a punchline. There's a lot of different mechanisms, but I would say if you had to boil it down to a Nerd Night talk that you need to finish in 15 minutes and you're already running behind, I would say that a punchline is just a way that I think of, okay, what would be a surprising way for this sentence, situation, or joke to end? It's kind of like you're going down a path and then you want to take a quick left turn and see where you go. There are a lot of fancy theories that kind of describe this: benign violation, incongruity. There's a lot of different names for it, but I guess at the most basic Nerd Night running out of time level, I would say, what is a surprising way for this to end? This is a joke that I wrote that I particularly like. Statistics show you are more likely to die from a bee sting than a shark attack. Not if I'm in the water. The way that I write my jokes, I like to think of other logical explanations for things. And even for my jokes that aren't necessarily about science, I think that's why a lot of people, I guess if you could say that's my style. A lot of people still like my non-science jokes because it does have that kind of different way that I use logic to explain a situation. Other ways you can make a punchline. So you can do different metaphors and associations. So like my joke that I said earlier, NASA's a lot like church. You can make 2 columns of things that you want to compare. What are things NASA does and what are reasons people go to church? And I actually wrote out a list of things and I was like, okay, well, NASA's trying to find a way to leave Earth. And church, you're trying to find a way to like have a better life after Earth. So that's kind of the similarity that I made. You could probably think of a better comparison than this. And if you do, feel free to write it in the chat and I would be happy to read it. Another way is wordplay. Wordplay is so fun. It takes a lot of skill. Some of them, especially if you want wordplay that doesn't make people groan. This is one of my jokes. I took a computer coding class when I was in middle school, meaning I learned the importance of a missed period long before I hit puberty. And I like that joke. I think nerds appreciate that joke. You can also do mixing. So that's when you kind of mix 2 situations. Another way of saying that is, okay, you have a certain situation like, okay, a shark is in a water. Okay, what if you take that shark and put him in the mountains? It's kind of like you take like a cut and like a copy and paste, right? Or like a cut out of one situation and you displace it in another and see if that logic kind of holds. All right, this is a joke of mine that, yeah, it's not very good, but whatever. This is a tweet that I did. When someone touches your bare skin with a cold hand, you can mix it with a pop culture reference. And that was like when Gollum was like, leave me alone, Mixing, a very popular way people do this is with pop culture references. Like WAP, like Cardi B's WAP, so much mixing comedy there. All right, I am very much running out of time, so I will quickly go through these. When I approach science stand-up, one thing that I do is traditional stand-up is usually pretty negative. People's attitude towards that can be summarized in 4 words according to other comedians in this book called Comedy Bible. you can flip it on its side, and I try and make it more positive because I want to promote people to be interested in STEM and to spread STEM education. So I always try and say like, oh, isn't it cool that we know XYZ about science? Or isn't it weird? Or isn't it scary? I don't try and punch down or put down science because I feel like now we're at a very special time where we really need to promote science. Does science comedy have any value? This is I curated the I Am SciComm Twitter account back in July, and I did a poll, and I found out that people thought that yes, it could be good for educating people and changing minds. And what I found a couple of studies, and I'll tweet these out. So just check my Twitter after this at Kasha Patel. They found that yes, this one was particularly for climate change stand-up. It increases science engagement. And they said, but it has to be good-natured. This is a study from Colorado. It has to be good-natured. So they talked about, certain humor techniques like wordplay, the things that I mentioned before. Another study showed that an audience perceived level of a science comedian's expertise was increased if that person was funny, which is really great. They're a good communicator. They can make you laugh. People have more confidence in what they're saying. And then this was one of the most interesting applications I've seen of science comedy or using humor is parallel argumentation. And this can be used to combat misinformation. So when I told you about that mixing, I gave you that bad example with Lord of the Rings, that can actually be used, this mixing idea, parallel argumentation, where you have logic of one situation. What if you pull that out and do it for another situation? And this is actually done by many scientists and psychologists, but in particular, John Cook is the one who kind of brought me into this because he studies climate change communication. And this has actually been very prevalent in COVID communication and combating COVID communication. So this is, follow him on Twitter, John F.O. Cook. And he writes cartoons and he's saying, okay, the curve is flattening, we can stop social distancing. And then he compares that to someone with a parachute. The parachute has slowed my fall, I can take it off now, we're okay. And that's not what, that's not helpful. And we talk a lot about, I talked to John, it's a really interesting conversation on my podcast, Science Comedy Paradox. It's called Cartoons and Climate Change. So I highly recommend you listen to that because it's a very interesting story. We talk about like people who's actually changed their minds. So yeah, it's on iTunes, Spotify, all that stuff. Okay, upcoming events with DC Science Comedy. If you would like to learn how to do some science comedy, that is another part that I do. I do my science comedy stand-up, but I also try to work with people who are interested in this, and I do workshops with DC Science Comedy. And actually next Sunday, I bring professionals all around the world trying to do these things. Next Sunday, I have this fantastic science educator who actually studies the impact of science music videos, and he actually teaches students in California to do science raps. So we're actually going to be learning how to write science raps and poetry if you don't like your voice. And he's going to take us through that process, and you're going to get the chance to do that and then workshop it in real time. And then I'll probably do a virtual open mic later on. So that way we can present that information. And I'll also have working with the Maryland STEM Festival, all virtual, all October on Saturdays. Again, I'll tweet all this information out. So there will be a lot of shows, a lot of upcoming science comedy. Okay, I think I'm out of time because I see Matt's face now. So there's a lot of stuff. Feel free to message me on any of the social media, and hopefully I'll be able to answer some questions. Sorry.
Great. That was I laughed out loud at the period joke, even though I've never had one. So it works across all the gender spectrums. All right, so we had a bunch of questions. First one I wanted to know, you mentioned when you were doing your research or sort of your measurements that you were measuring laughter for science and non-science-based jokes. What was it, sort of measuring the length of laughter or amount of it? How were you measuring laughter?
Yes, so I measured it in seconds. So I measured the seconds it took me to say the premise, and then how many seconds of laughter came afterwards.
What is it like doing stand-up to a one-way webcam?
You get used to it. There's definitely a learning curve. Like I've probably done around this is a modest estimate, maybe 60 Zoom comedy shows. And there's definitely there's a learning curve. And I think I've gotten better at it. And that's why I like to stand up. And sometimes I don't have laughter, like this. So you just kind of have to, it's really hard with new jokes, because with new jokes, I don't know how they perform. So I just, keep talking. You don't really wait for the pauses, which you would in real stand-up.
Right. You'd be happy to know that your challenge of making a list of NASA versus church was accepted in the chat. And Nirav came up with NASA versus church. Room full of people talking about a man above the earth, both interested in the heavens. So I guess it was more of a list than a joke, but we're getting there.
I like it. Good start.
All right, so I guess can we end on a warm and fuzzy anecdote? Do you want to share your connection with some people in Orlando? Maybe your cousin?
Yeah, so this is kind of fun. Nerd Night really brings people together, and I'm so excited for when we all go out and we meet people again. And I don't know about you guys, but when you're single, you try to go out and you're like, I'll meet someone at this place, and then after a while, being a lady, you're like, nothing's gonna happen. I've done this 1,000 times, nothing's gonna happen. And it turns out that actually worked out for my cousin who lives in Orlando. Maybe he's out there watching. I don't know. Hey, Kunal, if not, it's okay. You also have a baby. And he met this wonderful lady at Nerd Night Orlando, and he kind of wooed her, and she gave in, and now they're married and they have a Nerd Night baby. So magical things can happen at Nerd Night anywhere, but particularly in Orlando.
That is definitely one of dozens of Nerd Night babies we now know of, in several dozen marriages and engagements. So we take all the credit and no credit at the same time. I don't want to be responsible for any of this.
Fair.
Yeah. All right. So Derek, Morgan, Chequita, if you're all still there, can you fire up your webcams one more time? Thanks everyone for joining us here for part 3 of our 4-part Nerd Night Stream You in September series. Remember everyone, this is being recorded and will be posted right here at facebook.com/nerdnight in a moment, in a matter of seconds after I hit end. So thanks everyone. We appreciate your time. Share it with everyone. Wave,
Thank you.
smile,
So glad to
laugh.
be here.
Yeah. And also let's wish our Nerd Night Miami friends that no one gets COVID from sitting in an aluminum tube for 2 hours, which seems crazy. Morgan, you must be you're very beloved that she would do that for you.
She rushed back.
Great. Okay, so thanks. I got nothing else. I think that's it. So thanks everyone. Thanks for giving us 2 hours of your Sunday evenings again. Check out the recordings, and yeah, at some point we're gonna do something face to face. We don't know where, we don't know when, we don't know how, but it'll be exciting. So thanks everyone. See you 166 hours right back here for our last part of this series. Thanks everyone. Bye.
Take care.
Bye.
Good job, everybody.
Bye.